Howdy, y'all. I'm Professor Parks, PhD, and tonight I am going to be showing views from our 32-inch telescope here at George Mason. Due to the tremendous support that I've gotten through my Patreon, if you'd like to become a Patreon, you can see the scrolly bit at the bottom. Through their support, I was able to get a new planetary camera, which designation I cannot remember off the top of my head. It's a ZWO ASI something or other. Maybe I can see it right here, actually. ASI 183MC. And so last night I installed it, and there was a little bit of a problem with the dome, so I wasn't able to really put it through its paces. All I was able to do was to get first light. Those of you who are Patreons, I have posted videos of that onto my Patreon page. Again, they're not all up there because for whatever reason, my iPhone just decides that it doesn't want to actually upload things properly. But anyway, that should be up there sooner rather than later. So anyway, tonight, what am I doing tonight? So what I'm doing tonight is I am, again, putting the planetary camera through its paces. Right now, I've got it on Jupiter. There are some clouds out there coming and going. So, we're going to get what we're going to get. What I'm going to want to do is, what I want to look at is things like, what is the view of how well the centers of view of the planetary camera to our main science camera, how well those match up. So it's easy to switch from one to the other, or how easy it is to switch from one to the other. And I also like to see just whether or not I can look at things other than planets with this thing. Can I look at, say, the Orion Nebula with it? So we shall see. So without further ado, what I'm going to do is do. That's the wrong button. That one. Let us share that screen. That is the wrong screen. That's the right screen. And let's see if we can get that a little bit bigger. Nope. There we go. All right. I'd like to see if I can get this a bit bigger. So I am... Nope, I want that one. Yeah. I think I'm going to stop messing around with that and start messing around with this. So yeah, what you're seeing here is a whole big fat of nothing. Well, actually, you're seeing clouds. Is really what you're seeing. So what are we meant to be seeing? This is an image I took earlier of Jupiter using our main science camera. Our main science camera is a 4K by 4K SBIG chip. Again, I've forgotten the designation or the model number off the top of my head. That's not really what matters. What matters is that this is a camera that has a field of view of roughly 25 arc minutes. And it is monochrome, and we shoot through filters so that we can shoot through filters for a variety of different reasons. Some astrophysical, some for astrophotography. The issue we have with this camera is that it's a bit limiting with its field of view. Its field of view, as I said, is 25 by 25 arc minutes. That's roughly the size of the full moon. And so when we look at things like the moon or things that are of comparable size, certain galaxies, certain planetary nebulae, things of that nature, then we have a very good sampling of the image across pixels. You want to get as many pixels onto an image as you possibly can in order to really be able to see any kind of fine detail that would be available based on the size of your telescope and the atmosphere you're currently looking through. For us, that means planets, which are typically Jupiter and Saturn, namely, are, depending on where they are in their orbits, are only a few to a tens of arc seconds in size. So let me give you a sense of that scale. Move this over here. So that's essentially what the full, like there's a little bit of slop up and down. But if you were to look at the entire image of this is the entire image taken by the 32-inch telescope of Jupiter. And so you can see there's a lot of empty space. Jupiter is rather small in its angular size, or in its size relative to the field that it's in. So in order to really look at it, oh, here you go. Here's a better image of it. Here's the entire field of view, and there's Jupiter sitting right there. I'm going the wrong way. So really, in order to see anything of Jupiter, you got to zoom in pretty significantly in order to see any kind of detail. And you can already see oops. Apologies. I think my computer is lagging a bit. You see that it's pretty pixelated when you get up into its grill. So this was earlier tonight. The other thing I wanted to point out, and this is true, I found for both the and I hope folks can hear me out there. I haven't really actually checked. Probably should check. This is true for both cameras. This is true for the S-Big camera and also true for the planetary camera. Is that the dynamic range of this system of Jupiter and its moons is rather large. It's kind of like, it's akin to exoplanets around stars in that Jupiter is significantly brighter than its moons. Not quite to the same order of magnitude as exoplanets and their host stars, but Jupiter is significantly brighter than its moons. So the thing that you have to compromise on is either you can concentrate on looking at the moons, or you can look at the surface features of Jupiter. In a single image, it is very, very difficult to do both. Your camera has to have what we call a very, very, very large dynamic range. Dynamic range is the ability to distinguish the whitest whites from the darkest darks. You know, HDR, if you're a television fan or a gamer out there. You have to have a high dynamic range in order to do that. And so what I've done here is I've stretched the screen, or stretched the brightness such that we are only really looking at a very broad range of pixels. But if I were to change that, if I bring this in, we can see now that Jupiter is washed out, and we can see a couple of its, 3 of its moons. I haven't had the time really to check which of these moons it is, but maybe later I'll open up Stellarium and we can figure out which of these moons there are. I believe the 4th moon is probably, actually, the 4th moon is that one, if I'm not crazy. So these are the 4 moons of that Galileo saw: Io, Europa, Callisto, and Ganymede, going from inner to outer. Yeah. All right. Again, if the sound is bad, actually, I'm a little paranoid about that, so I'm going to check it. I think the sound is coming through. Yes, it is. Sweet. All right. Well then, I will do that. All right. So what was I going with? 4 moons of Galileo. Those those are the ones right there. But this is about testing the planetary camera. And so right now, whoa, here we go. We actually have Jupiter. Now, in contrast, this is the full frame of here's Jupiter, here's the entire field of view of the science camera. That's a little better, actually, a little bit more apples to apples. This is basically the full view of the planetary camera to give you an idea. And here, the other one is 4K by 4K. Here we're talking about, as you can see over here with the resolution, this is around 55 or 5.5K by 3.7K. So we're getting a significantly larger number of pixels going on here. So you might be wondering, well, this looks kind of washed out. Also, the other thing to note is because of the optics involved, mirrors and lenses tend to flip things depending on the situation. This orientation is not the same as we see here, and that is basically due to the fact this camera has not been properly rotated in order to compare the two properly. All right, so I'm going to take this down. There we go. Oh no, it's going away. Settle. So yeah, I'm fighting clouds at this point, I think. Which is why it's coming and going. No, I don't. Do that. What I'm doing here, just to get you an idea, is that with a digital camera, with a cell phone camera, you just hit the button, click, it opens up the shutter, allows light to hit the sensor, and it takes an image and then downloads it to you. Here, I have a lot more control over how the camera or the image is made. Primarily right now, what I'm fiddling with is the exposure. So right now, it is taking 5-second exposures. It's opening the shutter up for 5 seconds, allowing light in, downloading the image so that I can see it, and then repeating that cycle continuously. So this is a continuous live feed. And for those of you who have just popped in, like I said, I'm battling clouds right now. According to the forecast, it should clear up later on. But that's the reason why the Jupiter appears to be, well, basically non-existent at this point. So what I'm going to do is, and I just remembered that the title of this stream is called Shooting the Moon. So what I'm going to do is, even with the clouds that we have, the moon is so bright it will typically blast through them. So I anticipate that the moon is not going to be hidden in any way. So let's go over there, do that for a while, allow the sky to kind of clear itself out, and then we'll come back to Jupiter. All right, what do we got here? That one. All right, so you got the sky, which is basically a point-and-click planetarium program. We're over here. I really want to see if we can do the Andromeda Nebula later, but again, I think the clouds are sadly in that part of the sky. So let's go over to the moon. Big, bright, beautiful. Yeah. Hey, howdy, Stephanie. I'm glad to see you around. And yeah, When I was walking in, it seemed to be pretty good coming in. Really didn't need to do. I've decided that I am going to stick with. Well, now I have decided that I'm going to stick with StreamYard because honestly, there's life is too short for me to fiddle with OBS. But now that I'm looking at this, I need to figure out a way to actually get the screen that I'm sharing to be bigger. But anyway, that's here nor there. What am I looking for? That's what I'm looking for. Here you can see the telescope in all of its glory is now moving with the dome so that it can move. And you can see here's the sky. Basically, I don't know if you can see that very well, but I can. This is camera 3. I know there's a way to do this. Nope, that's not what it is. 1. Wow. All right. 4. All right. Anyway, you can see, I thought there was a way to easily change this to 1 camera. There is. There you go. So yeah, that's the cloud. That's the sky that I'm dealing with right now. So hopefully, like I said, it should clear up pretty at some point, or at least that's what the forecast tells me. Telescope has moved into position. We're just waiting on the dome to cooperate. All right, here we go. And wham! Yeah, I'm just overexposing the shit out of this. We are looking at the moon. It is very, very bright. There we go. Maybe. It is automatically trying to find the right combination between exposure and gain, I think. Right. We're just going to do that. How about that? How about, oh no, this is, oh, I see what's going on. What's going on is the reason why it looks funky is because this is literally clouds coming in and out of our field. So that is when the cloud, when it's clear, the moon is really, really bright. So I'm going to put it on auto, and yes, we're going to have a little bit of a chaotic mess for a while as it does this. But one of the things that's also different between that this camera allows us to do that the other camera could not is, well, one, we're shooting color rather than black and white. With our research, like I said, we shoot in black and white for a reason. We filter it via color, again, for reasons. Here, this instrument is primarily for public use. What we're most likely, what we want is something that can give folks, particularly virtual folks, a glimpse as to what they would see if they were actually looking through our telescope. As much of a glimpse as it's possible to give electronically. And so we wanted it in color. And what is going on? Why is the telescope not tracking? Huh. Drifting. Let's go. Yes. Occasionally, we've been having some problems with the moon doesn't track at the sidereal rate. It doesn't move with the stars as the stars move across the sky because it has its own internal, its own intrinsic motion. But it's close that it shouldn't be just drastically drifting across my field of view. We've been having a little bit of trouble with the tracking, and hopefully that will be the only time that I have to do what I just did, which is basically just go back to the same object, just re-slew to it. What was I saying? I was saying before, when we are with the science camera, we're limited also by shutter speed. For the science camera, the shutter speed is approximately half a second or thereabouts. And so you're not really able to take good images that are less than half a second because the shutter basically gets in the way. I mean, technically speaking, with the software, you can take an exposure that is 0.01 seconds or 100 milliseconds, but you're going to get some kind of effect of the shutter in there. Here, this camera allows us to have exposure time down to the microseconds, which is very, very useful if you're looking at something tremendously bright, like Jupiter, for example. So right now we're looking at the moon, and we're looking at it with an exposure of roughly 27 to 28 milliseconds or so. So it's taking an image every 20 milliseconds and then bring it back down. So again, the flashes of brightness are due to what is going on? Are due to the fact that we have clouds in the way. Now this is bizarre. See here, this is just kind of off top. Craters come in a variety of different ways. There are shapes and sizes. This is a lovely example of a crater with a central peak. Here's another one over here. There's a couple more over here. So, that's interesting. Sorry, it's the telescope just shifted, just shifted for some reason that I am not familiar with, or I don't know why it did it. It did it on its own. It wasn't a huge shift, but it was a shift. So I'm kind of puzzled as to what's going on there, but yeah. You may also notice that not only the brightness changing, but the focus seems to be coming in and out. And that's the reason for that is because of the fact that we have an atmosphere, and the atmosphere is going to blur out the images that we take. When the atmosphere is still and there's not a lot of particulates in it, for example, if it's very calm, then you can find a very nice clean focus. But if the atmosphere is turbulent, if the stuff, technical term, that's in the atmosphere is being moved around at any kind of high rate of speed, or if the differences in the physical characteristics from one patch of the atmosphere to another, such as the density, the temperature, the humidity, that sort of thing, if that is very varied, not homogeneous across the sky, then you get a lot of fluctuation like you can see here. But I think this is actually pretty good focus. No, Charlie, that's in fact a space station. Stephanie says, I've started paying attention to the moonrise in recent years. Amazed how much it moves today. Yeah. That's one of the things, that's one of the projects that I'm having my introductory astronomy class, is to look at the moon over the course of a semester. Right now, the project is designed to basically look at just lunar phases, but I think I'm going to continually add to it because I'm not entirely happy with it. And here we go again. The telescope is, for some reason, moving. I'm not entirely certain why it is moving. I think it's moving back to where it's supposed to be. Or it's just being difficult. Well, here you go. I was going to scan around the moon, but apparently the telescope is going. Oh no, it stopped, and it is going again. See here, you can see a nice mountain range here. This is known as the Apennines. If memory serves, this is the Apennines. Lunar mountain ranges are named after terrestrial equivalents. So there's the Alps in there somewhere. Typically, or more than likely, what this mountain range or the cause of this mountain range is not tectonic, is not a compression or compression of the crust of the moon. Certainly not due to plate tectonics of some kind of subduction zone or anything of that nature, but it's actually the remnant of a crater wall. So it's an ancient crater where most of the crater has been destroyed via one mechanism or another, and then you're left with that ring. You kind of can see it down here, and I'm actually you can see here. Oh, well, we were down to like 9,000 microseconds. So, all right, this is interesting. I have to say that telescope likes to embarrass me. It doesn't always seem to work as well as I would like it to. All right, let's do this. All right. Let's go up. Okay, up is down. Good to know. You can kind of see what I was talking about with the crater, and that you can kind of, this is a circular, kind of imagine that this used to be a crater but was filled in by basically a lava flow very early on in the lunar history. But let's keep going down, down, down. No. Oh, no, down is left. Down is left. So right is down. You can see how precise our worm gear is. Um, doo, doo, doo. The field of view of what you're looking at, you might be wondering how much of the sky we're seeing at the moment. And the field of view we're looking at is roughly 7 by 5 arc minutes. So, top down wise, you're looking at roughly 1/6 of the moon. Left, right, you're looking at something that's a little bit larger than that. So, right is down. Wobble, 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 wobble. And down is. Nope. Down is right. Right is down. Okay. That means. Damn it. Yes, someone's shaking things. Up. Up is left. Let's bring this back into position here. Mm-hmm. So you might have been asking, Rob, how do you know, Professor Parks, how do you know that this is the Apennines? Well, the reason why I know is because these three craters look very, very familiar to me. This would be Archimedes, this would be Aristarchus, and this would be Autoclytus. Um, these are craters that I've used in an astronomy lab that is to demonstrate Galileo's first attempts at selenography, or to basically map out the surface of the moon, not just in, up, down, left, right, longitude, latitude sorts of ways, but also to try to figure out figure out whether or not there is depth and height to these objects. You can see from the shadow, although it's kind of hard to see with it keep bouncing around, but you can see that there's a shadow here inside that crater. And based on simple geometry, you can measure the shadow lengths and you can determine the rough depth or height of a surface feature. In this case, a crater, you'd have a depth. And if you find a mountain, then you would have a particular height. Oh, wow, we must be getting really into some cloudage. Yeah, kind of. In that case, maybe the clouds are bumping the light around. Well, funny you should say that. Kind of, sort of, in a way. If you replace the clouds with the atmosphere, and then the atmosphere does kind of refract and reflect the light around, playing plinko. Probably a little too. This is weird. Telescope is not quite behaving itself on a small scale. It seems to be shifting on its own for reasons unknown to me at this point. Again, the brightness contrasts are due to clouds moving over the image, and the camera, I've had it on auto exposure, so it's trying to find an exposure that won't blast out the image, but will also still allow you to see detail. I may need to take that off. Oh. Let's see. There we go. All right. Actually, what I'm going to do is this. I'm going to see if I can find the Terminator. Yeah, let's zoom around the moon. This thing over to the right, I believe, is Tycho. Is the crater Tycho? Well, you can definitely see the limb of the moon. Hopefully it will stop. There we go. Oh, nice. It's almost like I meant to do that. Okay. Let's see here. Where did I put that? Mm, 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 mm. No, I didn't want to minimize the whole damn thing. Wrong one. That one. You go down. All right, that'll work. All right, let's see here. Let's zoom out. Let's play with focus. What I'm trying to do is I'm trying to get that limb, the edge of the moon is what we call it. The technical term for it is limb. I'm going to try to get that as crisp as possible. I think I'm going the wrong way. Yep, definitely going the wrong way. Let's see here. Let's move. Oops. I want to go. I want to make the thing go down, so I want to go right. There we go. That was the original focus. Ah. Hmm. Now it's going. Now it's doing weird shit. I think that's the best focus I can get. And I'm kind of really getting concerned about why the telescope is moving around so much. All right, down. Want to go up. Whee! Oops. Oh no, that is up. There's a beautiful mare, some cratering. And there we have the Terminator. Terminator is the fancy term for the dividing line between bright, the daytime part of the sky and the nighttime part of the moon. The part of the moon that gets daylight and the part of the moon that gets night or does not get daylight. What I wanted to show was, I did this last night. There was a particular area that I found that was very, very cool. Oh, now we're at 2-second exposure. So apparently it is cloudy. Yes, it is. It is very cloudy. All right, I'm gonna let it do its thing, and what I'm going to do is I'm going to take this opportunity to publicize this stream. So here we go. Let me do this. Copy. Discord. Right. Show your stuff. Right. Yeah, I think that's enough. All right, so let's go back to. Yeah. All right, advertising away. All right. So we're back down to 2-second exposures. So I want to go down, so I want to go right. What's going on, buddy? What is going on? All right. Oh. So I want to go right. That means I need to go down. Right? Where's the left? Maybe it's left. Or up. I want to go that way. I want to go that way. Ah, there we go. Well, that'll work. Assuming the clouds don't get in the way again. I'll let this settle. What I want to focus in on is this right here. Even though it's bouncing around, hopefully you can see that this is actually a crater, very much like this one is. But you can see that the craters I was showing you before are round. Typically, a crater, when looked at from the top down, is a circle. But here it is definitively ovular. And the reason why it's ovular is not because of its intrinsic shape, but because of the angle we are looking at it. It's called foreshortening. This may, in fact, actually be lunar rate. This might be because I am not tracking at a lunar rate. I'm starting to become very convinced of that at this point. But why is it sometimes not tracked? Like, why does it stay? Yeah, that's what I don't understand. So again, if you to keep going with the idea of foreshortening, here is a crater that is more seen top down. You can see that it's roughly circular, whereas here, when you get closer and closer to the edge, you can see that there are, in fact, because this is nearly full. This moon is nearly full. As you get closer and closer to the edge, you can see that the craters become more ovular in shape. And again, that is not because of their intrinsic size or intrinsic shape, but rather an observing effect. That is which we call foreshortening. So effectively, what this is showing is that the moon is a sphere. Moon around. Let's move around. Let's see. Nope, that's arc seconds. Arc minutes. always choose wrong. I need to get the camera oriented properly. I'll do that on some other day that I'm not live streaming. All right, well, that was obviously the wrong way. All right. Moving across. Crap. I completely forgot which button I was hitting. I think I was hitting up. Well, that didn't work. I'm so not used to using this kind of field of view, so it's I kind of want to just zoom out so I know where I am. Oh, and it's also cloudy. Gosh darn it. Stupid clouds. All right, let me look at actually no, Blue. There are a few examples of craters that appear to be gouged that actually are very elongated, but for the most part, the way that a crater is made is actually due to an explosion. And so, regardless of what angle the incoming projectile comes in at, it's the explosion that actually causes the crater from the impact. And so, because of it being an explosion, it's going to explode in a spherical distribution. And so, you lose the information as to how inclined the object comes in, or the impacting angle of the object. So yeah, that's the reason why most craters are circular. But there are a few small examples of impactors where the impactor was small enough, or at least slow moving enough, that it did actually gouge out part of the surface rather than just explode like a bomb. But yeah, all of these craters that we can see here, those are, we don't really know what the impact angle was. I think from a statistical point of view, you can assume that the most likely angle was around 45 degrees. '70 actually does rotate, but you would have to believe that in the heliocentric model in order to accept that. If the moon did not rotate, then as the Earth went around no, I don't think you need it. So let me see if I can. Let's see if I can do this. So synchronous rotation makes it appear as if it's not rotating, but it is. All right. So we've got the face of the moon. We have got the Earth. So the face of the moon always points towards the Earth. So as it rotates around, it is constantly, let's see, can we do this? You can see the face of the moon. I'm going to do top-down view. It's the 8 is always pointing towards the Earth as it orbits around. But if it were not rotating at all, then that means that in this location, the 8 is pointing to your left. And as it revolves around the Earth, then it would continually point over to your right. And our perspective, according to our perspective, we would see a different side of the moon. If the moon were not rotating as it was revolving around the Earth, we would actually perceive the moon as rotating. But it's only because the rotation period of the moon is exactly equal or reasonably equal to its revolutionary period, which is why it keeps the same face pointed towards the Earth at all times. Eventually, gravity is going to tidally lock both objects. Eventually, after probably hundreds of millions of years, if not longer, what's going to happen is that both the Earth, so you can think of this lettering as being the face of the Earth, and the 8 as being the same, there's the face of the moon. As the system revolves, both bodies will present the same face to each other. And so if you were to time travel to that time, if you wanted to see the Earth rise or set, you would literally have to move around the Earth in order to see that happen. But if you're an astronaut on the moon or a future inhabitant of the moon, you actually would see that with the Earth. In order to see the Earth rise or set on the moon, it's not a matter of time, it's a matter of location. You have to actually move across the moon. You have to circumnavigate the moon in order to watch the Earth rise and set in elevation or in altitude. We do take, yes, and that is called tidal locking. Howdy, Al. Yeah, right now we're getting a whole bunch of clouds, so the moon is in there somewhere. But I was badly explaining synchronous rotation. Jump them hurdles. It's not a hurdle. I don't understand why that would be considered a hurdle, Stephanie, if you have basically synchronous rotation, that that in order to keep the same face to the moon has to rotate as it has the same. I don't know why I'm having such a hard time communicating tonight. The explanation, to me, the explanation is not overly complicated. It just simply is that the rotation period of the moon is exactly equal to the rotation period of the moon, which is explained, again, through gravity and tidal locking. There's an interesting, and I don't know if I can find it. Maybe I can find it. A number of people have done this. They have taken a time lapse of the moon over the span of a month. And so you can see, or near the span of a month. And so you can see that it's really cool because you can see the moon change in phase very smoothly. But also on top of that, you can see that the moon actually somewhat wobbles. And what we refer to that as libration. So the rotation period is not exactly equal to its revolutionary period. There are times where you can see more of one side of the moon than you can of the other, and then back again. And yes, tidally locked moons are very, very common, particularly in the outer edges of the outer edges of, not edges. Jupiter, Saturn, they have tidally locked moons. Uranus and Neptune have tidally locked moons. Got upset when filming Earthrise. Yes, Earthrise was filmed from orbit. Hey, the moon's back and it's moving again. Oh, no, now it's not moving. What are you doing, computer? I don't understand. Oh, it actually looks like it's kind of calming down. Hmm. Let's see what we got here. Check out. All right, Jupiter's setting. So let's go to Jupiter and see what we can see. I don't think we can see much because Jupiter is basically beyond, just beyond the dome in that direction, and and yeah, it's pretty freaking cloudy. Bev is mad at Blue Marble Science. No, you don't say. That's so unusual. Bev never seems to be irritated with Blue for you know reasons. Howdy, Bob. Uh, trying to right now, Bob. I'm trying to fight clouds, which is a losing battle. I'm also trying to fight why my telescope is moving erratically on like arc-minute spatial scales, angular scales. Let's see. 70 says it's very intriguing how it's so dull in the telescope and um, so bright in sight with human eye. Uh, Believe me, if you were to actually look at the telescope, if you were to look at the moon through a telescope that is not filtered, it would be exceptionally bright. The reason why it appears dull in the camera is because with the camera is trying to compensate for contrast. Essentially, it's trying to be able to get the range so that you can see bright and dark features next to each other without too much difficulty. So it's difficult. It's trying to compare a digital image to what you would see with the eye is somewhat problematic. Uh, but as I was saying before, with this camera, we are trying to give the best representation of what you would see through an eyepiece if you could be at our location and see it. And so our pointing is not great, but I'm hoping I can bring it back in. How about this? Or not. All right. Mm-hmm. Pardon me while I whip this out. Oh, it's down here. Sorry. Stupid Windows 11. Fucking hate Windows 11. Sucks. Start. Oops. Yeah, this is the last, we've had clouds for a week here, which is one of the reasons why I'm doing this now is because even though I know that it's cloudy, is because we haven't really had a good opportunity in a long time. What I will do here. I am switching over to the science camera, which has a much wider field of view, in the hopes that I can actually find Jupiter. I envy you, clear skies in North Texas. Why? Where's my image? Oh, there it is. Okay, I think that's Jupiter. The difference in focus between the science camera and the planetary camera is ginormous. I really don't want to wait to get it into focus. I just want to get it centered. So I think that's good enough for me. I know what I'm doing, theoretically. So I'm going to take as many shortcuts as I possibly can. Bev does not understand the terms used in Euclidean geometry, does not acknowledge non-Euclidean, dislikes math and reality. We had snow and, oh man, we just had a lot of rain and clouds here. Did I hit up? God, I hope I didn't hit up. I think I hit up. I think I did. Move. I have long since stopped trying to understand why Bev misunderstands things. Like, at this point, I'm utterly convinced that Bev does it on purpose. He doesn't want to learn, and he will mentally do just extraordinary mental gymnastics in order to not understand the point that you're putting before him. Ah, good. Trying to find Jupiter. He's on the level. Howdy, Wolf. Mm-hmm. All right. That should be close enough. Ba-bam! Jupiter and its moons. All right, let us. Okay, that is a 1 second exposure. You can kind of see the camera is kind of, I don't know what's going on. You can definitely see the three chips, the red, green, and blue channels. I'm entirely certain what that is, but let's see if we can actually see Jupiter. Because we're stupider. Again, I don't think it's going to look great because clouds and it's very low on the horizon. So yeah. So here is, I think, here's an image of a movie that I took earlier today of Jupiter when it was, higher in the sky and there weren't a lot of clouds or as many clouds. I don't know why it's black and white. I need to look into, that's something else I need to look into, is why the video capture is only monochrome and not color. So just got this camera today and or not, I just installed this camera yesterday. So right now I'm kind of just fiddling with it just to see what we can do with it. Jupiter's melting. Howdy, Chris. This guy really does still believe in the Jesuit heliocentric model, despite it having been utterly destroyed. I believe that Copernicus was a Dominican, actually, not a Jesuit. And I have yet to see it be utterly destroyed, but I'm sure you're going to inform me as to how or why it is. So what we can see here is, well, there's Jupiter. There we go. Right now, Jupiter is at an angle of 9 degrees, altitude of 9 degrees. That doesn't make sense. At 9, what is our limit? I've sworn our limit was 15. So yeah, basically I'm very much at the limit of the telescope before we start actually, looking into the dome. So I think we're going to have to say goodbye to Jupiter. The more, the lower down you look, the more atmosphere through which you have to look, and the blurrier things get. So let's do something else. M42. No, let's go there. Yes. Let's go to the Orion Nebula, the best nebula there is. And it's big enough that I think I can kind of just get in the ballpark and find it. Clouds seem to be going away. That's cool. Next, the stonemasons will jump in on it. Yeah. Oh, you know what he's talking about. The Jesuit he's talking about is Lemaitre, the guy who first postulated the idea of the Big Bang, which really can be independent of heliocentrism, I guess, maybe, I don't know. But Copernicus certainly wasn't a Jesuit. I believe Copernicus was a Dominican. Aristarchus certainly was not a Jesuit. He wasn't even Christian. Okay. Well, we seem to be pointing in the right direction. All right. Let's see what we got here. It's not what I wanted. Yes, Lemaitre. Can't remember his first name. Jean-Luc? I don't know. Anyway. Guy who first came up with the mathematics behind Big Bang cosmology. He was a Jesuit. Oh, Ryan, yes. Okay. I think we're close. So left is left, up is down. Jesuits were spreading the globe lie since 500 BC. Holy shit. That's impressive. I didn't think there were Jesuits before Christ. That's it. Those were some far-thinking individuals. Wow. That went the wrong. That went way too far. Let's do this. How about that? Well, for some reason, in certain people's minds, Jesuits are essentially kind of like Masons. They are a secretive order bent on the destruction of mankind. Um, they don't believe in God. They believe in the Pope, and so therefore they believe in the devil. They are worshippers of the devil, and so they are, part of a globe cabal trying to eat your soul. Kind of like stonemasons, but religious. Don't say dome. Yes. Sorry. Didn't mean to trigger something. I don't know what you would call it other than a dome. At least it's not called a firmament. All right, that's got to be close enough. Hey, there she blows. Sweet. All right, I'm gonna auto. That's the trapezium. Dun, dun, dun. Oh, wow. That's starting to look good. Focus kind of sucks, but yeah, check that out. Yeah, focus really sucks. What's the exposure at? 9 seconds. I think. Try this. Sweet. What's it getting the exposure up to? All right, I'm going to take this off auto. I'm going to do 15-second exposures. What the hell just happened? 7, 8, 6, 4, 3, 2, 1. Blammo. There we go. Awesome. This will be fun. Let's move out. I love focusing on images every 15 friggin' seconds. That's going to be awesome. Yeah, let me see if I can. This is not tenable. All right, let's do a 5-second. Every 5 seconds. Okay. All right. I think that's more doable, workable in terms of trying to fiddle with the focus. Fireflies that are caught in a big black bluish thing. That big black bluish thing is actually the remnants of the, well, somewhat, it's not quite remnants yet, but that is the prenatal cloud these stars came from. And I think I'm still dealing with cloud cover. Come on, give me one good image. It's not flopping around. Birth juice. That is pretty ew. All right. Let's try. I think I'm going in the wrong direction. I think I have determined that. think I'm going in the wrong direction. Yep, definitely going in the wrong direction. Wish I could add a soundtrack. What is going on? Why does the focus suck ass? That looks better. So I had a chat with QE a couple days ago. Inadvertently, actually, it was not planned. I've got it recorded. I edited a little bit. I'll be putting it on my channel for those of you who, if you can stand his voice, you can, watch it. Effectively, it was just, him insulting me basically just saying, sure, okay. And yeah. But it's interesting, I guess, in a sense that it's what happens. It was fun to see what would happen if I didn't engage with him from a hostile perspective. And yeah, it got kind of weird, actually, particularly near the end. But no, this is definitely getting worse. Fudge. Look at there. You're going to get a P1000? All right. Okay. That is the flat earth camera of choice. Well, P9000 and now the P1000. I really don't understand why the focus is so damn bad. Jesus. This is embarrassing. Howdy, Cygnus. Oh my God, yeah. He he brought up Whitsitt. Unsolicited, by the way. He brought up Whitsitt in our conversation. He referred to them as, hold on, he used alliteration, which is what I appreciated. The treacherous, treasonous traitor. That's what it was. He refers to Austin as the treacherous, treasonous traitor, which is a little redundant, I gotta say, but it is. It was nice. It was fun. What am I focusing on, or attempting to focus on? This is the Orion Nebula. This is this nebula is roughly, I think, 1,400 light years away. It is a stellar nursery. It is what we would, in more generic terms, it is a molecular cloud. It is a cloud composed of primarily molecular hydrogen, helium, and other heavier elements. And due to density irregularities within that cloud, that causes portions of that cloud to collapse in faster than other parts due to gravity, and that contraction will then create new stars. These stars that you're seeing here, those are what's known as the trapezium because, hey, they look like a trapezoid. Those were probably some of the first stars that were born from this particular molecular cloud. They are very bright, very luminous stars. And I think we are now getting back into clouds. I shake my fist at thee. All right. Okay, folks, I think I'm starting to get real hungry, which is probably why I'm not communicating very well. At least that's what I'm going to blame it on is food. So I'm going to probably wrap this up because it doesn't seem as if the sky wants to cooperate with me. But of course, later on tonight, I'm sure it's going to clear up beautifully and things will be all kinds of wonderful. I also don't know why I can't get the damn, clouds, dude, clouds. Why are you trying to focus through clouds? I don't know. Seems like a good idea to me. Well, definitely see the. I know it's not really in focus. It's not great focus, but you can kind of get a glimpse as to. Nope, wrong way. Of just how cool the cloud itself, the nebula itself is. The gas surrounding it. I've always seen either images that are around 25 arc minutes in size or larger, much wider field of view. I've never actually seen a close-up image of the Orion, any of the parts of the Orion Nebula, at least not from the ground. Let's see. Chris, good night. Thank you for being around. I appreciate the support. Those old girls who grind their own lenses for DOMs. Oh, we actually have a lens. We actually have a mirror that was given to us along with some grinding equipment. So at some point, our student club will actually finish grinding I think it's a 6-inch mirror that could be used for a Dobsonian. So yes, that is, I've done a little bit of mirror grinding myself in the past, and yeah, tedious as shit. It is not something that I would love to do on as a hobby, generally speaking. All right, let's go for broke. Let's do a 30-second exposure and then call it quits. Let's see. Don't suck. Don't be crappy. Don't be. It was crappy. All right. Yeah. Definitely closing this up. Okay. All right. All right, folks. Thank you for being here with me. I apologize. I don't know why I'm apologizing for the weather. I wish the weather were better. When I looked at the report, the weather was supposed to have cleared by now. It apparently has gotten worse. So yesterday, the weather was wrong in my favor. Today, the weather is wrong, not in my favor. That's how it kind of goes. So yeah, I definitely appreciate you watching and going through this. This is something that this camera, again, was provided to, or I was able to purchase it through funds for our Patreon. So thank you to my patrons for your continued financial support. I am going to be using this camera very, very often particularly over the next couple months or so, because I really want to see what I can do with it. And I will be sharing those images and those videos onto my channel, and also I'll make exclusive images for the Patreons. Right now, there are a few videos on my Patreon account that are Patreon exclusives. Those are basically videos of me putting this on and getting the first light for the telescope. I probably won't do a live stream with this again, just simply because I need to be able to focus in on it. So who knows? We'll see. Maybe I'll do another one. Maybe I'll do another live stream with the camera in the past or whatever. Maybe not. But what I am going to do is I am going to have a hold on a second. Let me check real quick. There it is. I am going to be doing a 5-hour, 55-minute, 555 subscribers celebration tomorrow or tonight. Basically starting at let's say 9 o'clock Eastern, and I will go for 5 hours 55 minutes. Go through, and we'll have New Year's Eve, at least for me. We'll celebrate New Year's Eve later on, and I will bring on as many people as I can snag in such short notice as between now and then. So I hope you all will join me for that. I have not done a 5 subscribers celebration, 500 sub celebration before. So I'm hoping to be able to get folks like Matt, I Can Science That, Toon, Blue, just folks that have been with me for a long time. Just get them on, have a chat, see what's going on. Maybe we can do some talk about gravity or what have you. So yeah, basically it's kind of a last minute thing because that's kind of how I like to do things. And yeah. So I'll keep an eye out for that. Keep an eye out. I'm going to be posting or putting out a stream notification for that later on today before I go to sleep. So with all of that, oh, thank you, Al. Thank you. Appreciate their support. And those of you who are, and I was talking about the patrons, but all of you who have watched, all of you have been around with me since the beginning of this channel. I deeply appreciate it, and I love the support that you've given me. So with that being said, I do have an outro, which I am going to now play. All right. Peace out and clear skies. At least clearer than this.